In this video, I'll be discussing Kepler's law. So, Kepler's law. So, Kepler provided three laws. First law is laws of orbit. So, Kepler informed that each planet revolves around the sun in an elliptical orbit with sun at the focus of ellipse. So, for example, I am taking here, this is the elliptical orbit like this. So, we know this is the ellipse. So, we can have this is the foci. So, we can assume either sun here or at this position. So, this in any orbit. So, this is the orbit. Let's say this is our planet which has mass m. So, it will be revolving in the elliptical orbit around the sun. So, sun, our planet, and elliptical orbit. This is Kepler's first law, which is law of orbit. Now, second, laws of areas. So this law states that the radius vector from sun to the planet sweeps out equal areas in equal time intervals. So let us take the example here in the same diagram. Suppose that this is the sun. At certain instant, let's say our planet moves from this point to, let's say, this point. So it is creating certain area. So this is the radius vector, right? So this is the radius vector. It is sweeping right now this much area, let's say A1, and suppose at any instant it is moving from this point to this point. So of course, if we can draw here, let's say our radius vector r dash. So this is sweeping this time this area, say A2. So example here, seeing this diagram, so as areas are same, so that means area A1 and A2 has to be equal. Okay, while I am assuming that time interval is same, which is t. If okay, so for this also it is t, for this also it is t only. So this is the Kepler's second law, which is laws of areas. And then we can move toward the third one, which is law of periods. Third, So Kepler stated the square of the time taken by the planet about the sun in revolution or revolving one cycle will be proportional to the cube of the planet's mean distance from the sun. So basically, in simpler language, I can say that time period, so square of the time period is proportional to distance. If I am taking, let's say, r, so r cube, where r is the distance of the planet and this is average from the sun, correct? So I can state that time period can be represented as t square, this is r cube. I can also say that t is proportional to r to the power 3 by 2, and I can state here t square upon r cube is equal to constant. So this is true for every planet. Okay, so this is the Kepler's third law. Here, suppose that if the elliptical path is there, let us say this is our elliptical path. So now here, what will be the value of r? So suppose that if this is the situation, then this is the radius, which is the minimum one, and this is the maximum, let's say r2. Then we can write this r2 is r max and r1 is r min. So we can write that r mean distance is r minimum plus r maximum divided by 2. This is the average, and then we can utilize in the relation t square proportional to r cube, right? So I believe that you got the points of Kepler's law. You should remember it. Okay, very important in gravitation. Many times it is helpful. Fine. Yeah.